to one and all present here. My name is Abhisha, Assistant Professor in Mechanical Engineering Department in Parle University. We are gathered here for learning and understanding the promising topic on manufacturing and applications of composite materials. We will gain a deep knowledge on how to manufacture and different applications of composite material. Now, I would like to introduce our speaker, Mr. Saurabh Modi, sir. Sir had completed his master's, that is MTech, from Nirma University in Design Engineering, his bachelor's from North Maharashtra University in Mechanical. Currently, he is pursuing his MSc in Global Logistics Operation and Supply Chain. He had 6+ years of academic and 5+ years of industrial experience. He had guided many graduate and undergraduate students. He had published many research and review papers in different journals and conferences. So, I would request Sir to please start the session.
Hello everyone. Today's our topic is manufacturing and application of composite materials. As Abhi has introduced me, I am working in the field of composite materials since last 3 years. So today we'll focus on the application of composite material, and we study a lot of composite materials in material subject. So we'll try to interrelate that things. We'll go, as this is the first lecture, so we'll go very basic, and we will try to simulate what we have studied and what the same thing is applied in the industry and how the process flow goes. Okay, I hope everyone will enjoy this 1 hour session. First, I'll introduce my company. We are located in Rajkot, and EPP is established in 1986. And I'm very proud to say that it is in the top 10 list globally for FRP manufacturing components. So it is not only that this company is recognized in India only, but it has a global presence in Europe, in Southeast zone, as well as out of India in like US and everywhere. Now, once we start composite material, I guess the first thing that comes in our mind is like we do this to improve the properties. It is like the same thing that is in case of metals and alloys. Metal and alloy is very common, so we do it on common basis, but it is not the case with the composite material. Okay, you may have studied this thing in our some of the subjects that composite material can be defined as a combination of two or more materials that results in better properties than those of the individual components used alone. It's like uh, if we compare about metal, because in mechanical we are more familiar with metals. Aluminium has density of 3000 kg per meter cube, whereas steel has density of approximately 7800 kg per meter cube. Now, if we need density of like 5000 or 4500 in between, so we are left with two choice. Either we can change the material, that is the first thing, but what happens if such material is not available? We need a particular property that is not common in any of the material. Whether, and when I talk about material, it could be metal, it could be plastic, it could be wood, it could be composite, anything. So the thing is, whenever we need a particular property which we cannot find in the commonly available materials, then the use of composite material arises. It is like as common as that. If we need something, then we need to do something. It's that simple. So you can find the second point, that in contrast to metallic alloys, each material retains its separate chemical, physical, and mechanical properties. Okay, so You can use that metal, that alloy, or that material only when you are in requirement of that properties. Okay, so the two constituents are, if we go for met 1 second. હા દક્ષિણ પેલો લેક્ચર આપવાનો છે ને એટલે છે બોલીશ તો ખરો ને પણ okay, so in case of composite material, two things matters a lot. The first thing is reinforcement, and second thing is matrix. Now, what is it? It's simple words. The purpose of matrix is to hold the reinforcement. Whatever property we are trying to attain, we will attain through reinforcement only. Okay. Yeah, sometimes matrix may help, but in majority of the case, reinforcement is the main thing through which we attain this property. Okay. So the main advantage of composite materials are their high strength, stiffness combined with low density when compared to bulk materials. These are general materials what I am talking about, allowing for weight reduction or in the finished part. Now, when I am talking this weight reduction, we may have come across carbon fiber material, right? And the main example of using this composite material in aerospace industry or commercial airline industry is the Boeing 787. I guess Boeing developed it from 2004, and the first commercial plane they delivered in 2009. So that is the first plane which made excessive use of this composite material. They used 50 percentage of composite material, and they claim that this plane can reduce the fuel consumption by 20%. So that is the use. They achieved the same properties but with reduced weight. So this is the strength of composite material which no other material can do. Okay. Now it's these are just common properties which we can achieve, that reinforcing phase provides strength and stiffness. In most of the cases, reinforcement is harder. As I had already told, that reinforcement is already always harder than the matrix, stronger or stiffer than the matrix. It is usually a fiber or particulate. In our case, in our company, we usually follow fiber. Particulate also we follow in, but it is limited to some particular application only. So particulate composite have dimension that are equal in all directions. Okay, this is because we need not only we not only improve the properties, but it's like directional properties as well. We have higher strength in some direction, higher impact strength in some direction. So that's why we use fiber. So now, what could be the shapes of this reinforcement? So it could be spherical, pellets, or any other. It could be regular or irregular geometry. Doesn't matter. Okay, the important thing, it should achieve our properties as well. Okay. Now, whenever we use a fiber, we are not trying to use, first of all, pallet or any other. Suppose we have decided that we will use a fiber. Okay, so in that case, two things are very much important. The first thing that comes is the diameter. As soon as you have small diameter, so you can achieve higher properties. That is because smaller the diameter, smaller the defects. Okay, it's just as simple as that. So in that case, your L by D ratio becomes much more important. Okay. So see, uh, you can read the third point that continuous fibers have long aspect ratio while discontinuous fiber have short aspect ratio. Then continuous fiber composites normally have a preferred orientation while discontinuous fibers generally have a random orientation. So this we do everything to achieve the properties as well. It could be unidirectional, it could be woven cloth, it could be helical. Okay, you can understand through this figure. See, first figure represents unidirectional. Okay, so it's like tensile stress definition, which we study that it is an axial pull, or in case of compressive, that it is an axial push. So this is aligned in one direction. So in the direction in which stress is about to occur, we will align either in vertical or horizontal based on the imposed loading. Now, this is the second, third we use maximum to achieve the properties. That is, and we just combinedly call it woven roving. First one that is in written, it is 0 degree, 90 degree, and woven is written. And the third one it is called as roving, but we generally call it woven roving because sometimes we use combination as well. Then the last also, last two, which is chopped and mat. So this also we called as chopped strand mat. So this is the uh, not matrix for us. Okay. Now what I just simply told you that defects can be reduced if your diameter is less. So, you can read the second point that as a general rule, the smaller the diameter of fiber, the higher is the strength. Right? But definitely, but often the cost increase as the diameter becomes smaller. Now, whether it's a wire drawing or whether it's a fiber, production process remains the same, like you may have studied extrusion or something. Okay, extrusion process or wire drawing process, when we have a big collet and we use a piston cylinder kind of arrangement with a die at the end in which we have a hole, and our diameter will solely depend on that hole. So suppose we have a higher big diameter hole and we have a small diameter hole, and you try to just imagine that you are pressing the metal from the back and it has to pass through that hole. So bigger diameter hole is there, definitely it is advantageous manufacturing point of view. And if the diameter of that hole of the die or mold is smaller, then definitely it will create some manufacturing difficulty. And once manufacturing difficulty arises, then it will definitely come up with some of the cost. Okay, so same thing is here. We need to manufacture the fiber. So if we need to manufacture the smaller diameter of fiber, so like I mentioned for metal, the same rule gets applied over here. So some cost addition will be there. So we are trying to use a less diameter fiber so that there is not a single defect in it, and we can achieve our properties. But at the same time, what will happen? It will come up with extra code. So in our mind, it should be very much clear, right, that we want to use less diameter, but we need to invest some more amount as well compared to the regular one. Now the thing is, continuously we are talking about this matrix and everything. Okay, which fibers you can use and what could be the materials? Generally there are two things. One we call it FRP, and one we call it GRP. So FRP material is called as fiber reinforced plastic, and GRP material is called as glass reinforced plastic. And our industry, there is a very slight difference between both of them, but our industry is called as FRP industry, right? Fiber reinforced plastic. So the question is, which fibers? There are a lot material, but on the basic side, what you can understood is like glass, aramid, carbon, because you can imagine this thing, okay? Because see, glass is a brittle material, and if you will compare, uh, matrix is always a ductile material, whereas this reinforcement could be brittle because it's more harder. So at the same time, it is possible that it is brittle. You can imagine, see, glass is always brittle, okay? Carbon, you can consider it brittle. This both material have one thing is common, that they have a bit higher hardness, and especially in case of carbon, okay? So it could be discontinuous or continuous, like we mentioned. And here, as a uh, matrix, we use polymer. The simplest example is what you may have come under your study is when in construction work, uh, we when trying to fill up this lab, we use two different material. One is cement and the second is TMT bar. So in that case, you can assume the TMT bar as a reinforcement and cement as a matrix. So the similar concept applies over here. So we talk about reinforcement, that in which shape would it could be. It could be like fiber, or it could be pallets. So here there should be something for material as well. Which material? There should be something for matrix as well. Which material should be? So here we have a limited kind of materials for matrix, and that is more or less it is polymer. Okay, metal and ceramics doesn't come much, but polymer is the first choice. And in the second point, you can read that it has low strength, low stiffness. Like I mentioned, that matrix will be always softer. Its purpose is to accommodate the reinforcement. So it may not have higher strength, it may not have higher stiffness, but definitely ductility would be there and softness will be there. We cannot imagine our matrix as brittle. Yeah, it could be, but it is not the preferable choice. Okay, so in third point, you can see the matrix performs several critical functions, including maintaining the fibers in the proper orientation and spacing and protecting them from abrasion and environment. Now, why orientation is important over here? Because initially I told that sometimes we need to achieve the directional properties. Okay, so if we want to achieve the directional properties, then orientation is definitely important. Okay, so this properties depend on this orientation and their spacing, and why you want to protect it from abrasion and anything from the environment, because see, environment plays a major role. Suppose you are using a TMT bar, definitely it will not get corroded, but if there is some material which gets corroded, that is like harm from the environment only. So that is the indirect purpose of this matrix, to protect them. Okay, and at the end it should form a strong bond. Okay, it should not decompose when it gets in use. So that is the basic. Okay, there is like how this slide represents that how much amount you can add the reinforcement. 70 percentage volume is the maximum. You can't go beyond that. Okay. So these are some x-axis represent percentage volume, and y-axis represent the strength, module, and cost. So it's very clear that you add the percentage, you add the volume, you will get higher strength and higher property. It's quite simple. Okay, so this is like now the normal uh, classifications. Okay, that composites are divided in particulate, fibrous, and in fibrous. There is further classification like unidirectional, bidirectional, then any random orientation or so. But this all thing, as of now, you can't understand because it depends on the what property we need to achieve. So there is a bit harder calculation behind that. Okay, it is the same thing. Okay, now you can see titanium on y-axis strength is mentioned. Okay, steel in mechanical terms we consider a bit stronger material. Titanium we consider a stronger material. Aluminum is not that, but it's a metal. Okay, but see, carbon epoxy is achieving a higher specific strength. Even its weight will be much lesser than this metal. So that is the advantages. Okay, so here it's just the comparison of specific strength and modulus. Again, fatigue you may have studied or you will study in machine design. Okay, where there is endurance limit and everything will come. So it is assumed that world's 60 to 70% component gets failed due to fatigue. And in case of fatigue, the component fails below the yield limit only, because generally we mechanical people are familiar with ultimate strength, and we have a mentality that once the stress reaches ultimate, then it will fail just because of our stress strain curve. So here in fatigue the case is different. So what I want to convey that you can assume, you can check the top line. Okay, this FRP or GRP composite material is much better in fatigue as well. You can check the line. The steel line is, the one point is starting at 400. Okay, and it's gradually down, whereas here it is starting in between 750 to 700. So you can assume the higher mechanical properties. Okay, these are some of the application what I initially mentioned. It is very much used in aerospace industry to reduce its weight. And what the I mentioned the application in Boeing 787. Okay, it is for that only. Okay, now nowadays even in cars also they are starting using, but it's limited, it's bit lesser. So these are some of the application. Now this smallest division with which I am starting is called SMC. Okay, SMC in term it is referred as sheet molding compound. So the raw material for production is this compound. This whole diagram represents how we can make the compound, and once compound is ready, you can use it. Okay, see, it is produced on a moving build process. Okay, and they are made of job strand mat, what we discussed initially, and roving strand sandwich between two layers of film of resin paste. So here the resin will be your matrix, job strand mat or rowing will be your reinforcement. Okay, you can add different fillers, different additives, different curing agent to make this process a little bit faster. Okay, so this is the whole process. At the end, you will get your compound. When it is at the last stage, it is final sheet material cut to length. And our starting raw material is the bottom rule, where it is written lower carrier sheet supply rule. That is your starting rule. Then after, stage by stage, we will add chop strand mat, we will add woven drawing, and it will pass through several rollers, and at the end you will get your material. Now we need to cut the material. That is also a thing, that why we need to cut, because for each and every, suppose this is the operation, and this blue line are our compounds which you need to pick. So we actually calculate that how much volume will be required to produce a component. Okay, so based on that, we adjust this last cutting length. Okay, so based on that thickness or its length and other dimensions, we initially calculate the volume, because once we'll place it, if the volume is bit on lower side, it will not reach to the uh, thin sections, and the shape which we are trying to attain, that we will not get it. Okay, so this diagram simply shows it's very common process, because here we use a press, okay, to produce the required shape. And the similar thing you may have studied in your manufacturing process subject. This is very common operation. Okay, and see at the bottom it is saying that layers of SMC, these layers are the same which you obtain of SMC are placed into the heated tool. Through closing the tool, the material fills the cavity and polymerizes. After complete the cure, the parts are released hot with compression molding. Highest mechanical strength can be achieved. Okay, so now this is the product. This is very simple thing. We produce a lot items like bigger storage tanks, pipes, cable trays, a lot item we produce, but an initial level, this is the smallest division and simplest item. Okay, so here this is the our final product once it comes out through the press. Yeah, definitely you need to fast use fasteners and everything to assemble it. Okay, this is another, there is a this junction box term is referred to the box which is not having any kind of accessories. If you add any mechanical instrument in it inside it, or any electrical instrument inside it, then in that case it will become its name will change, what I want to say. And it has two parts, the bottom box and the top one is called as lead. This is very similar component. So we are manufacturing it. So you go to your home and check whether we have you have our boxes installed at your home or not. In my home we have EPP box installed. Okay, so this is the simplest meter box which we use. Okay, and this is metering cubicle. Actually, Adani and Torrent Power uses this. Okay, this is again, you can see the name Adani Electricity is already written. So we manufacture this kind of box for Adani, and these are quite bigger size, more than 1000 mm by 1000 mm, and its depth is also nearly 300 mm. Okay, so see, initially I called it as junction boxes because it was not having any attachment. Here I just put inside the meter fixing arrangement and a glass. to check the reading. So it is box only, but the name has changed to meter box based on its application. Okay, this black portion is called as gland. It is called as cable gland. Okay, then this is again metering cubicle. This is multimeter box because we put a number of meters inside it. Okay, this is distribution box. This is fuse box. So it's like our SMC process is limited to this white box only. The rest of the things we need to outsource it, and then we fit it and supply the entire assembly. Okay, it's just a simple BPL board. Such kind of thing is very uncommon now, but previously in our older houses, number of BPL boards were used. Okay, and this is, I'm calling it IP66. If you see our watches or something, then fast track watches, they also write that it is IP66 protected, it is IP67 protected, or it is IP55 protected. It actually represents this standard that water cannot go inside and it cannot damage the inner instruments. So that is the rating. Okay, similar thing is coming IP66, IP67. Okay, you can check the image of this boxes that it looks like water will not be able to enter inside. Okay, this is matter enclosure. Uh, it is not our primary product, but we produce that as well. Okay, this is cross arm. We generally, this you will see much more in rural areas. Okay, so these are not the, this is not the product which we produce through SMC, so we'll not check it now. See, the smallest division which I considered uh, has very small component, and it is not that much complicated component, which because when you complete your 4 year of bachelor degree continuously in each and every subject, we hear industry, in industry it is like that, it is like this, or they follow this, they follow that. So we comes under a bit pressure. Okay, that's why I have chose this product. So you can imagine it was not complicated product. It is not difficult to understand this product. Suppose the one who knows AutoCAD, and if someone will say him to produce the drawing, then again the drawing preparation is also not that much difficult. But still, I'll say that just for this small unit or small product, EPP is getting more than 55 crores of order per year. It's not that much big. I mean, this is the smallest division. Even the cost of this boxes is also starts from 250, 300 to 15,000 to 20,000. So cost is also not less. So what I want to say that it is not the case that always the things are that much complicated in industry. Okay, so this is very simple product. Okay, and here these are some of the clients or companies which are using these boxes. Like, if previously, if you have observed in our villages and all this, we find metal boxes. Now the case is from last 6 7 years that metal boxes are replaced by this SMC boxes. Okay, so there are some states which use it in very high amount. In our Gujarat, we have four distribution companies, that is MGVCL, which stands for Madhya Gujarat Wheat Company, then PGVCL, which stands for Paschim Gujarat Wheat Company, then Dakshin Gujarat Wheat Company, DGVCL, and rest is UGVCL Uttar Gujarat. In Rajasthan, there are various. AVVNL stands for Ajmer Vidyut Vitran Nigam Limited. Suppose it's JVVNL, then Jaipur Vidyut Vitran Nigam Limited. So ultimately, Tata, Kerala, Adani, then Maharashtra, then Telangana, Andhra Pradesh. These are the states that they are using these boxes in very high amount, and the annual requirement is more than 10 crores of boxes. So you can imagine the uh, volume of the sales which can be achieved with just very simple product. Okay, now this 2 3 slides will focus that how we are, suppose we are able to produce this product. We have set up our manufacturing facility. We have hired manpower. So, from which stage we can start? Okay, this the first thing. Generally, the what clients are mentioned, that these clients are majority government clients. Okay, so in India, the government always publishes tenders. Okay, it's like inquiry only, but tender is a bit complicated process for us. Okay, so the thing is, initially, now as of now, forget about all the things of this composite, that basic and everything. Okay, now we are following that how we will receive the inquiry and how we will convert it in the order and how we will manufacture it. Okay, so what will be the stages? So this slide particularly represents the thing which we have studied in our books. Like, then we will move to next slide where the actual case is. So first we receive the inquiry. Now we will check that whether we can manufacture it or not. If we are able to manufacture it, then we will prepare the quotation. Now again, the thing is, why we need to prepare the quotation? It's just a simple box. So if it's a simple box, then we our prices must have been fixed. But the thing is, at each and every time, the accessories gets changed. So, and there is always fluctuation in the market. So we need to take the current rate, and then after we need to fix the price. Okay, then we submit the price, or we can call it bidding as well. Then production, inspection, and dispatch, and the final step, the payment collection. So this is what we have studied in very simple terms, but actually how it works. See, this is the thing. To receive the inquiry, you should have a vendor registration. You may need a licensor agent. You may need a marketing person, and you may need a portal registration. The thing is, till we are not registered, we will not receive the inquiry. And if we will not receive the inquiry, then there is no case that we can receive the order. Okay, so vendor registration is the thing where you submit all your commercial documents, all your technical documents, your manufacturing facilities, your capabilities, and everything you submit it. The government board will check it, and if it is found satisfactory, then they will issue you a vendor registration certificate that okay, you can supply to us. So till date, if you are not having vendor registration certificate, it is sure that you will, suppose you are having only in Gujarat, so doesn't matter, Rajasthan is procuring it, Andhra Pradesh is procuring it, but as we are not having the vendor registration, we cannot get the inquiry. Okay, the listener agent is the one who has good context and he actually communicates on behalf of us. Okay, then marketing person, it's quite common, and that portal registration, it is similar to vendor registration only. But portal registration is important because each and every inquiry or tender is submitted in two stages. One is online and one is offline. So you submit the physical documents in file form, but you submit the same scanned document or soft copy of document in over portal. At the same time, to avoid this corruption and everything, tender is much more suitable because no one can check the price. Okay, so the system becomes very much transparent. Then okay, suppose now we have done all this thing and we have received an inquiry. Okay, so suppose the inquiry is like this. The first thing which we'll check will always be the technical specification. From that only we'll get to know that whether we can manufacture it or not. Okay, so this is the Tata Cross Arm. Okay, and this is the technical specification of it. Here they'll mention what are the standard requirement which you need to match, what guarantee you will offer, what kind of packing will be there, okay, and all other technical requirements. See this, they are stating the standards that while manufacturing you need to use these standards. If we are not having these standards, we can't quote. Okay, okay. Then this component will be installed in this particular climate condition because initially I told that crossarm is the component which is used in rural areas, especially for FRP. Now the 4.0 point starts with your technical requirement. Okay, that material is there, fiber reinforced plastic. Okay, then size is mentioned, tolerance is mentioned, then these are the stresses and properties which we need to achieve, which I was initially talking about. Ultimate tensile stress, but it is here even a normal second year student will also understand that the strength which they have mentioned is 50 megapascal, which is quite less. Okay, isod impact strength, the compressive strength, cross breaking strength, hardness, water absorption, dielectric strength. So these are the properties we need to achieve. If we are not able to achieve, then it's not possible to produce it. Okay, and at the same time, these are the other, this is the accessories. Okay. Then the type test. The type test is particularly important because once you are following a particular standard, then these are, you may have heard IRDA lab which is situated in Vadodara, then CPET lab which is situated in Ahmedabad. So we produce a prototype and that prototype will be sent to IRDA lab or CPET lab. They will check the properties and they will give us a report which we will give to client, and in that report we should have achieved that mentioned properties. Then and only then our we, product is valid, otherwise whether we have received order or not it may get cancelled. Okay, so type test is always very important thing. There is a difference between type test and acceptance test. Okay, once type test is done, we can't for prototype, then for each and every lot that we produce, we will do routine and acceptance test, but routine and acceptance test is done in our in-house lab. We also have a lab. Okay, so that you can do in your in-house lab, but for the sake of trust, initial prototype test to prove your capability to manufacture, you need to do type test in any of the NABL approved lab. Okay, so these are the other some dispatch and inspection delivery and guarantee and any other things which they need. So they in inquiry they will write like this. Okay, that these are the specification and this thing you need to achieve. Okay, and this is the drawing. It's again very simple drawing which you need to manufacture, but the important thing is achieving property only. Okay, and based on this drawing you should know that if you don't have die, so based on this drawing you need to prepare the dies as well. Okay, so that is the thing. So this is the point that whether it is in manufacturing range or not. Standards came into picture, dye came into picture, the properties and everything came into picture. And now if the answer is yes, that okay, it is there in the manufacturing range, then there is a management decision. But why? Again, why? The same thing, because if we want to produce a die for this, it will come up with some certain cost, because we are not, it is not our regular item. So what will be its development cost and standard? As I mentioned, okay, there are some quality checks like ISO now 9000. Do we have this certification? 14000, do we have this certification? QS 9000, do we have this certification? If we have, it's not an issue. But if we don't have, then we need to get it. So the product is small. So ultimately, each and every time we need to develop more and more sizes, because we can't rely on one or two sizes. So that is why management decision becomes important in each and every case here. Now suppose we have decided that we will do it. Okay, so in that you will have to go to proposal department to take out the costing, because ultimately price is the main thing in addition to technical. Okay, so uh, we'll prepare a BOQ. Okay, I think in EG also you may have prepared BOQ. It is the like simple way, it is the list of the items which is required. Then we will prepare the costing, we will prepare the GTP. GTP is guaranteed technical particulars. Then they have given us a drawing. We will also propose some drawing, and if there is any deviation between their drawing or our drawing, then we'll write the deviation that this is the change. But generally they don't accept such kind of change. Okay. Now the main thing, how we can bid for the tender. Okay, so when you will submit your document, what things they have given, like in vendor registration, you will have to prove that you are technical enough to produce this technical qualification. Again, it will come up with all technical documents, like what machineries we have, what instruments we have, whether it is calibrated till date or not, each and everything. Then once we are technically qualified, then the price portion will come. So the thing is, if you are not technical competent enough, then in that case price portion will not come. You are not allowed to check the price of others as well, that what they are bidding. Then it has, nowadays it has become very common that they arrange the auction. Like here, there were just before 2 3 months there was a news of Tata that they won the auction. So it is similar like that. Here you need to they arrange the auction, and you just need to enter the price, that at which lowest price you can offer is the one which bid or attend the auction with the lowest price, he will get the order. Okay, so now suppose you have got the order. Now The thing, can you start the production? No. You need to develop the prototype, what I mentioned. You need to generate the type test reports through the testing laboratory. You need to generate the die. You need to provide the client that prototype, and then if that inspection is fine, if it is as per their requirement, then only you can start your production. Once you start your production, then after also you cannot supply them. They will issue a delivery instruction. Once they'll issue a delivery instruction, then it's nothing but there will be locations mentioned in it that you need to supply this lot to this places with this quantity and something like that. But it comes after inspection. A person will come, he will check the boxes, and he will inspect, and if the inspection goes well, then only you will get the delivery instruction. Okay, so the thing we just this was the thing which you have studied in our books, and this is the practical thing how it goes. Okay, so today we have just seen two three things, that what is the composite material. Okay, the main two ingredients, like one is matrix and second is reinforcement. Then when you need composite material, okay, then what are the applications of composite material. And the we checked some of the simplest product, as I mentioned that with FRP we can manufacture pipes, we can manufacture these bigger storage tanks, you can manufacture a lot pultruded items, even we check ladder and everything as well. So a lot you can manufacture, but our focus was on SMC only. It contains just simple box and everything. And then after, the rest we understood is the process flow, that how we can receive the inquiry and we can complete that inquiry. But one thing that I forgot to mention is the FRP storage tank, FRP pipes. These things are majority used when there is a problem of chemical compatibility. In SMC it is not there, but suppose you want to store sulfuric acid, H2SO4 or HCl, and if you will store it in any metal storage tank, so in that case it will definitely get corroded within a span of 1 year. FRP always offers chemical compatibility. So that is why FRP storage tanks and other thing is used with a great extent. But on the other side, it has a problem as well, that FRP can never take up higher pressure. In FM we have studied pressure is equal to rho gs, right? So it gets applied in storage tank, that you can FRP tank can resist that static head. But if you want to store liquid or any fluid at higher pressure, then FRP is not a good choice. In that case, you will have to go towards uh, metal only. Okay, so this was from my side. Thank you everyone for listening me. Okay,
Thank you, sir. It was very nice topic which you have selected and a very knowledgeable topic which we have found out. And sir, whatever questions from the customer or we can say students and people will come, I will just come back to you through mail, sir.
okay, no issue. Thank you very much.
Thank you, sir. We will meet again, sir, in another webinar. Hope so
Okay,
for a
okay, okay.
collaboration with
Yeah,
you.
sure, sure. Okay, can I leave?
Yes, sir.
Okay.
Saurabh, thanks a lot.
Thank you, sir. Hello.
Hello.
Yes, sir. Thank you very
Thanks
much for
for
inviting me.
thanks for receiving the invitation and delivering a
Yes,
talk.
sir. Yes, my pleasure, sir. I hope it was fine. Actually, I didn't get
It
much
was
time to.
informative and thoughtful also. So let us have
Yes,
any other session also on the other topic in future if it is
yes, sir.
possible for
Sure.
you with your understanding. If we can plan, then we can do that.
Yes, sir. Okay, sir. Sure, sure.
Okay. Okay.
Okay.
Thanks a lot.
Thank you, sir.